Okay.
Okay, yeah, welcome to my session today about the Hiero project. I'm Hendrik. I'm the director of open source at Hashgraph. I worked on Hedera in the past, now one of the leaders of the Hiero project. I'm part of the technical steering committee and currently the chair of that committee. And within the Linux Foundation, where Hiero is a project in, I'm part of a technical advisory committee for the Linux Foundation Decentralized Trust. So for all projects about DLT, Web3 distribution within the Linux Foundation, there's this committee for. And next to that, I do other open source work too, which is on the Linux Foundation, and next to that on the Eclipse Foundation, where I'm a member of the board. But today we will concentrate on Hiero and LFDT. So let's start with the topic about Hiero with, again, general point. What is a distributed ledger, and what do we want to do here? And I always like to present that with a real use case that explains it quite good from my point of view, which is the use case of transferring money. So that's a real use case, including the Standard Bank, which is the biggest bank of South Africa, and the Shinhan Bank, which is like one of the leading banks in South Korea. And they try to figure out, okay, what does it mean to transfer money from an account that a person has at the Standard Bank to a private account that another person had as a Shinhan Bank? Like, you live in South Africa, your mother lives in South Korea, and you want to send money to her. So any idea about the cost, about how long it takes to do such a banking transaction, like in our digital world today? Any guess here in the room?
4%.
Okay, so I can show you what it is, what they figured out. So it's really about $40 doing such a transaction. And even worse, it can take up to 6 business days. So not just 6 days, but 6 business days, right? So there could be a weekend in the middle or a public holiday or whatever. And over that amount of time, the full transaction is not tracked, or it cannot be tracked by you, right? So you send money, and for several days, you have absolutely no idea what happens with that money until maybe 8 days later, boop, there appears an amount which is way less than the one you sent based on the fees on another account. And this is happened because there is no direct transaction happening from the Standard Bank to the Shinhan Bank. What happens in the real world is, since they are on different continents, different countries of our world, they do not transfer money directly, but there are those, I call it just here, global mega banks. I don't know what the real name is, like the big bank for everything in Africa, the big bank for everything in Asia. And instead of having this direct connection, you really need to do several steps, including those banks. And each of those transactions has a fee cost. Each of those transactions takes some time. And like what happens between two transactions, like when it comes with Swift to one bank and what happens to forward it with the Swift protocol to another bank is more or less unknown, right? That's a black box. So in a worst case, it could be that a person comes in the morning, checks, prints out all the transactions and do them manually or whatever, right? We just don't know. And that is why it takes so long and is so expensive. And those two banks figured that out by doing a research of it. And based on that, what they did, they created a proof of concept using DLT technologies. Especially in that case, they did it with the Hedera network. So they created something on the Hedera network. And what they did is they had a smart contract running in the Hedera network, and they created two token types in the network. So two types of crypto coins, of crypto tokens, of stable coins, to be correct. One was representing the South African rand in a digital way, and the other was representing the South Korean won in a digital way. Not like Bitcoin or Ethereum that everybody can use it and can do transactions with it. No, it was only created that way that only those two banks have access to those coins and can exchange those coins. And they decided, for us, those coins have the same worth as real money. At the beginning, they exchanged like, half of it. I mean, so that both of them still have the same amount, but have both currencies. And when then a transaction happened, the transaction is still doing that way, right? It took still like 6 business days to do it, but directly when the transaction comes, they execute it on this smart contract on the Hedera network. And with that, for those two banks who have that agreement, the transaction is done. There's a lot of things happening in the background, and it takes days until it's really done. But once the transaction in the smart contract is done, the amount appears on the other bank account. And that ended in a scenario where they were able to, I mean, those numbers are way worse than what it costs to really execute it on a chain like Hedera, because doing that on Hedera would be less than 1 cent and it would be less than 1 second. But since they have, like operations around it, applications around it that talk to the Hedera network and so on, their numbers were like, okay, it costs less than 10 cents, which means like they still have a fee, which is like 9.99 whatever cents. So they make still a lot of money with those transactions. But it happens in less than a minute, and it's completely trackable if you want to, because you could track it on a network. And that is, from my point of view, a quite good use case to describe where decentralized networks are really a good thing for, to create trust between entities that are working based on a decentralized network and exchange data, which could be tokens, which could in theory be everything. And the network I would talk or start to talk about today, because later we will talk about Hiero, but I cannot explain Hiero without talking a little bit of its history, which means I want to talk a little bit about the Hedera network. So the Hedera network is a decentralized network. It's a L1. And the special thing about the Hedera network is that it has the Hedera Council. And the Hedera Council here on the right, you see the companies part of the Hedera Council. It's not totally up to date. There's one new added, I think, like 2 weeks ago. But you can see like Google is there, IBM is there, Dell. Then, yeah, we have the Standard Bank, the Shein Bank we already seen, Ubisoft. We have a university somewhere. Where is it? I currently don't see it. Oh, yeah, there's the Madras University. Then we have Mondelez, right? So the cookie creator company here, because the idea of the Hedera network is to have companies in the council who run the nodes, the consensus nodes of the Hedera network, that sitting not only in different industries like cookies plus universities plus tech plus finance, but even all around the world. So we have companies from Asia, from Africa, from Europe, from North America, from South America. And by having those companies operating the nodes of the Hedera network, that network is quite fast. So that is one slide that was proven by the London Blockchain Institute, I think, where they checked about, okay, what is the performance of the Hedera network? And as you can see, like, it's proven that for all those different use cases, like doing token transfer, doing transfer of the native HBAR currency, or calling any smart contract, we're talking about more than 10K transactions per second in the live mainnet of Hedera, which is, if you have a look at other networks, way more than most of the other networks can do, like Ethereum, Bitcoin, or whatever. It's even more like we know from things like Visa. So as you can see, Visa can do like around 2,000 transactions per second, which is way less than the Hedera network can do. And with having those nodes only executed by those big companies in green data centers, the benefit is even that doing a transaction is has way less cost than other networks and costs way less energy than doing it on other networks. And the other great thing about Hedera is, and that came especially for us working together with the Linux Foundation, where I will come in a second, is that, and that has been published, I think, like 2 weeks or 3 weeks ago at tokenterminal.com. They did a research about the development of layer 1 networks, and Hedera is currently, after Ethereum, the network with the most action contributions on the development side, right? So it has like the most core developers working on the project. We already seen one sample of Hedera. Other samples are this one, which is Avery Dennison. I had no idea about that company before. I assume most of you don't know that company, but they do logistics, and they, for example, do for the sport brands Essex all the logistics. So just think about, hey, this is about, you know, Essex shoes and things like that. And what they, as an example, do is they store like all the events that, or let's say like that, all the different parts that are needed to create a shoe are created in different factories around the world, come together to a place, and then get manufactured. And all that is stored in events in the Hedera network, which allows that company to, you know, at the end, like you can see it here, have a barcode, and you can see then the legacy of your shoe, where all the parts are coming from, how much carbon footprint maybe the production had, what companies would be involved. I mean, you could do, yeah, you can do that with a SQL database. Why do you do it on a blockchain, right? So the benefit here is that they store it in a smart contract in a way that cannot be changed after having it stored there. So they already need today check that they work from a carbon perspective in a good way, and that they only work together with good factories and things like that. Because if something bad happens in 3 years, and you know a factory comes with bad condition for the workers, in worst case have children work there, they cannot say, oh, we have nothing to do with them, right? Because all is already stored today on the blockchain. Another example is ServiceNow, the help desk provider. They store for issues where they have specific SLAs, the hashes of those issues on the blockchain, whenever something changed in the issue. And with that, they can later verify that, you know, they answered within the given defined range of time and so on. We talked about that project already, so those are just samples. So let's move away from Hedera and become a little bit more generic. So there are a lot of distributed ledgers out there, right? We could talk about Hedera, we could talk about Cardano, we could talk about Bitcoin, Ethereum, whatever. But so what makes such a network trustworthy? Sure, it's decentralized. But another point I would like to talk about, which makes it really trustworthy, is the fact that how it's developed. And here it's super important to have such code developed in open source, because that makes it auditable. That allows to create standards, to create compatibility with other projects, that will avoid a vendor lock-in. Because if it's closed source and the company who creates it says, oh, we don't do that anymore, we don't care, you will have a big problem if you depend on it. If it's open source, you could, if you want, or get together with others and continue that project. And I mean, open source some years ago, people might be afraid of it. However, it's everywhere, right? So if you assume you are not using open source, maybe you just take out your phone. On the iPhone, you can now easily go to settings, general, and then legal and regulatory, and then legal notices, and you will see all the open source projects that are used in your phone with all the license and so on. And from my point of view, it's not only open source which is important to create such projects, it's even where those open source lives and who owns that code, which brings me to open source foundations. And as I said at the beginning, I'm active in 2 open source foundations. One is the Linux Foundation, the other one is the Eclipse Foundation. Let's again talk in a generic way about it, because what all those foundations do in a really great way, they work as stewards for open source projects and help open source projects to collaborate with other projects, get people working on that project, finding sponsors and adopters for that project, help those projects to be created in a vendor neutral, we will come to that in a second, and a secure way. And I think all that is very important for distributed ledger technology we want to build the next, I don't know, 10, 20, whatever years on. So how does that work? How does an open source foundation work? Let's assume we have a project and we have different players who work on that project. Here we have a financial institute, an IT enterprise company, a small company, and maybe even an individual contributor, right? And all of those people can work together on an open source project hosted in a foundation, contribute code to it, maybe contribute issues to it, documentation, do translation, maybe of documentation. All that is contribution, and all that can be done by all those different entities. So each and every project, especially when going to enterprises, need resources. Next to contribution, it needs a logo. Maybe you want to do audits. You want to be like, we are currently here with Hiero or the Linux Foundation booth in the exhibition hall. You want to be present at events and so on, which means resources are needed, right? And in an open source foundation, they have a specific ruling that don't say like, oh yeah, everybody pays the same here. No. If you look at that, this individual contributor really only pays a little bit. And maybe that is not even money. Maybe what this contributor gives to the project is the contribution he or she is doing, while the finance institute pays a lot of money into the project to move it forward. So all those people work together to move the project forward, and all give resources in a way that fits to their type, if it's a big company, a small company, or even an individual. But on the other side, and that is the important factor, when it comes to governments, all of them have the same voice, right? You as an individual have the same rights as Microsoft as a full company, if you as an individual are part of that project and maybe be part of the committee that is leading that project. At Hiero, for example, we have the technical steering committee that is driving that project forward, which has 9 people on it, some of them as individuals, some of them coming from companies. I'm, for example, representing the Hashgraph company on that committee, while the Hashgraph company is a member of the Linux Foundation, pays fees to it. We have individual people on that committee who are not a member of like paying fees to the Linux Foundation, but they have the same voting rights as I have. And I think that is the important thing here. And next to that, another very important thing is supply chain security, because that is often a problem with, like open source projects, let's say like in the wild, when working with open source foundations, all of them, or the big and important ones, have programs to help you with supply chain security, to create supply chains and use supply chains in your software that will, do not let all those different attack vectors, like somebody submit malicious code, somebody changed the deployed artifacts to something else. For all those, there are working groups or subcommittees. Like in the Linux Foundation, there's the OpenSSF. At the Eclipse Foundation, there's the Open Regulatory Compliance Working Group, which both really take care about supply chain security, how to make it right, and how to make it safe. So this whole bundle is, from my point of view, very important to create sustainable and trustful software that we can use in enterprises in the future. And one example is, which brings me to my main topic, the Hiero project. So the Hiero project is a project of the Linux Foundation, especially of the Linux Foundation Decentralized Trust, which is a subpart of the Linux Foundation containing all the projects that are interesting on distributed ledger, Web3 technologies. And what Hiero is, and that makes it a kind of unique, it's the full open source base of the Hedera network. So what we did is we donated last September, so mostly a year ago, the full source code of the Hedera network, including not only the SDKs you need to code against the software, but including even the software, the code of the consensus nodes, the code of the mirror nodes, all of that to the Linux Foundation, which is now owned by the Linux Foundation and developed within the Linux Foundation in a vendor-neutral way, because it's now not owned by Hedera anymore, and Hedera decides into what direction the project goes. It's now owned by the Linux Foundation and governed by a committee, which is the Technical Steering Committee, that currently consists, I think, 9 people from 6 companies, which is moving that project forward. And we've seen the slide about, oh, Hedera has the second most developers after Ethereum, right? That is because of this move. We had a lot of developers before, but this move really showed us how much impact it has to make open source right, to make it in a vendor-neutral environment. And so those are some numbers I checked. You see, it's like April 25th, so they are already old, but that was when we gave an update to the Linux Foundation about the state of this project. And from September till April, we got over 22,000 contributions to the project. I mean, contributions can be somebody created an issue, right? So contribution is not somebody reinvented the wheel and did, boom, super complex code thing. Could include that too, but could be anything. The important is it's really over 22,000 contributions where people contributed issues, documentation, or code to the project. And that is not coming from the, I don't know how many, maybe 100, 120 full-time engineers working on all those projects. No, it comes from over 400 people. And that is really great. And we were able to track those over 400 people to over 50 companies, where we found like GoDash, we found IBM and other companies. NVIDIA contributed code to the Hiero project next to the people from Hedera, as it was before. And that really makes this project being a real vendor-neutral project with all those companies coming together and contributing with the goal to create a project here that everybody can use to set up networks, to run networks, or to work against the Hedera network, which is just one network that is based on Hiero. But it's not that Hiero is replacing the Hedera network. It's more like Hedera is still a product, and there is a mainnet and testnet of Hedera running, and that will not be changed. But the full source and the full code of Hedera is now coming from Hiero. So Hiero is this open source project that everybody can use, and the product Hedera is still the main user of it, the biggest user. We already have others, if you will see on the next slide, but it's not that Hiero replaces Hedera or whatever. It's really like the source and one product out of the source. And you can create other products out of it. As, for example, creating private networks that are using all those functionality and code that is, already proven by Hedera. And there's one new project which is called HashSphere, which is coming from Hashgraph, the company I'm working on, which is a little bit like a Hiero network as a service. So if you want to run a private network, maybe in your company or together with other companies, HashSphere is exactly that. Because we, as the main engineers coming from the Hedera ecosystem, will help you to set up a network with how many nodes you want to have. If it's a private network in your companies, maybe 3 nodes is enough to have 1 node in each company. And with that, you already have a great distribution and you can already create trust because none of those 3 companies is owning the data, all 3 own the data in that case. And that is possible with, not only HashSphere, but with having Hiero as a 100% open project. As said, a lot of companies and even individuals contribute to it. We will come to it in a second where you can find it on GitHub and so on. And before we go into code and really have a look at what you can do with it, I want to talk 5 minutes about the Linux Foundation. So the Linux Foundation is the biggest open source foundation of the world. And the Linux Foundation Decentralized Trust is like a sub-foundation of the Linux Foundation, like you might know the CNCF, the Cloud Native Foundation, where things like Kubernetes, as an example, are hosted. That's another sub-foundation of the Linux Foundation, or the JavaScript Foundation. I think it's called JavaScript Foundation. That is another sub-project of the Linux Foundation where you find all those jQuery and whatever projects that are the core of mostly every JavaScript application. And in this Linux Foundation Decentralized Trust, you will find all the projects in the Linux Foundation that are about decentralization, about Web3, and so on. So here you can see all projects that are part of the foundation today. I can tell you it's growing. I know already about projects coming where we voted on to have them on the slide. So as part of the Linux Foundation, Hiero is just one, but we have another one. There was like for Hyperledger Identus, there was a workshop this week already, and we have people here from that project. I think next we will have Firefly here, right? A workshop about Firefly. You might know Bizu, which is one of the mostly used Ethereum clients that is now part of the Linux Foundation Decentralized Trust. And it's not only the projects, as said, all those projects need resources, right? And the Linux Foundation Decentralized Trust, and when I created that slide, I was really like, whoa, that is huge, is backed by so many companies already. So I just highlighted some here like Hedera, American Express, Chainlink, IBM, MasterCard, Oracle, or what do we have here? Walmart, Polygon, Ethereum, Citibank. All those companies are already now part of the Linux Foundation Decentralized Trust and care about the project we have just seen, right? And I think that is a really solid base to create enterprise software that is trustful, that is not owned by just one entity, but owned and governed by a group of big players, of small players, and of individuals. And that is, from my point of view, the main goal and main benefit here. So what I would like to do next, after this general introduction about what is Hiero, where it's coming from, I would like to do a small, live coding based on Hiero. And what we want to do is we want to use one of our SDKs. We have SDKs in totally different languages, like for JavaScript, C++, Go, Java, Swift, Rust. I see Python is missing here. I need to update that slide because we have Python SDK 2 as an example. And we will use, so we will do it in Java. because that's my language where I'm coming from. I could not do it in any other language. I can only do Java. But what we will do is we will create a small client that is using the SDKs to communicate with a Hiero-based network. And as we will see, a Hiero-based network could be Hedera or any other network. And we will see that when doing the live coding. So if you later want to try that out, there are some nice resources how you can start working on Hiero. One thing is that is coming from Hedera, but I mean, Hedera is based on Hiero, so it's 100% compatible, is the developer playground of Hedera, which is like an IDE, a minimalistic IDE running directly in your browser, where you can easily code small examples, directly execute them in your browser, and do your first transaction against a Hiero-based network. It goes starting from doing some token transactions up to deploying your first smart contracts to a network. And if you want to play with a network and work against a network, the best network for Hiero today is the Hedera testnet. That's a network executed and maintained by Hedera that is running in parallel to the Hedera mainnet. And you can create an account for free. We will do that in a second on portal.hedera.com. And what you can then do is do whatever, you can use any Hiero SDK, anything that is compatible with Hiero, and run that on or against the Hedera testnet. And with your account, you receive, I think it's 1,000, not 10,000, HBAR each day that you can spend on transaction against testnet to test things, right? This is not for continuous integration or something like that, but this is like for doing your first steps, for doing some manual checks and stuff like that. And so when you go to the Hedera testnet and do like, oh, I want to create a testnet account, put in your mail, we'll come to a page like that, where you see, oh, those is my private key, that is my account ID, and you can just copy those informations out of it and put it directly into your code as an example to run transaction against that Hedera testnet. So for today, I have prepared a GitHub repo. That is the URL of the GitHub repo. If you want to code either now here directly in the session with me or try it later at home, that is the URL. Let me stop the presentation now and switch to that. If there are any questions so far, that would now be maybe a good point to ask them, because give me a second, why I will share my screen. So let me remove the Zoom sidebar here. We are recording all that in Zoom. So let's go to GitHub, and it's under Hendrik Ebbers. So this is the URL. It's github.com/Hendrik Ebbers, which is my private account, and then I created a Rare Evo repository here, which is a Java project that shows you different ways how you can interact with a Hiero-based network. And what we want to do is, first of all, have a look at those different ways that you can use to interact with an Hiero network, and then have a look what different kind of network we can interact with. Because as good testnet is, I don't want to use that in CI. And as good Hedera testnet is, if I'm sitting in a plane without internet, I cannot work against that. So I need a different solution. And that's what I want to show you today. Oh, thank you. Yeah, I missed that. So it should be like this, maybe. Yeah. Okay, thank you. Here we go. Okay. So I have already checked out that project. In general, what we are doing now is all part of the README of this project. As said, it's a Java project. It's a Java project based on Maven. If you never coded in Java, Maven is the build tool that is used in that project. So it has a pom.xml that defines all the dependencies of that project, the Java version that should be used, which is Java 21. And what this project is doing, first of all, it's based on Spring Boot, which is like one of the most common frameworks in enterprises to create application with. And it's a small Spring Boot application with a small front end that we can use to interact with an Hiero network and create maybe some tokens out of it. So what it does is, let's have a look. We have our main application class, which is a classical Spring Boot application. And here we have this enable Hiero, which comes from the Hiero dependency for Spring Boot and says, hey, cool, let's provide everything I need for Hiero, including dependency injection for all the Hiero specific stuff and so on. And when looking in a controller, which is a view controller of our view, we have different things here that are injected, like in Hiero context, like an NFT repository and an NFT client. So those classes coming from the Hiero extension for Spring that is currently in development, which allows you, when going into the NFT client, to create an NFT, to whatever, associate an NFT to an account, and so on and so on. You have all those methods here, and then we have the NFT repository, what on the other hand allows you to, query NFTs, like what NFTs are owned by a user and so on. And all that is used in this view controller that is connected with a basic HTML page. And when I start that application, one thing I need to do is to configure to what network I want to connect and to configure my account plus my private key that should be used as an operator account to connect to that network. So in Spring, all that is done by application properties. So here we have Hiero, Spring Hiero account ID, Spring Hiero private key, and Spring Hiero network name. There are more things if you have a look at Spring Hiero. Oh, I need to type Hiero correct. Then you will see that there are even other things. Why is autocompletion not working? Normally there is autocompletion to all the Hiero properties. Anyway, so you see here we have those three important properties, and I externalize those into environment variables because I don't want to store my account ID and stuff like that into the project. So I have created a .env file containing currently just fake information. So we want to connect to a Hedera testnet. This is the account ID we want to use, and this is our private key. And what I will do now, I will change that to the original information of my account ID of my private key that I used at Hedera testnet, and then we can start that application and execute it against Hedera testnet as an example. So let's do that, and for that, I will stop sharing for a second because otherwise all those informations will be recorded, and I'm seeing nobody having a mobile phone here, so I think I can easily copy those three lines here, put them in, close that one, boom. Now we have the information here of my testnet account. And when I start the application, and let me share my screen again, exactly, thank you. So I started the application, and this application is now running on localhost 8080. And I mean, as said, it's a very basic application. So you can see I have a lot of NFTs already minted on my account at testnet. I can now just click mind NFT, which will mind a new NFT. If I refresh here, we see a new NFT has been minted, and we can see exactly that when going to Hashscan, which is a front end for the Hedera network, where you can select between testnet or mainnet, and we want to go to testnet. And let's have a look at this token. We see already it's a token that has been created right now. There's one supply, which is the one I created, right? And when going to holders, we see that is my account here. And when I go to my account and go to operations, we see I have this token create and token mint. So the token create is executed when I start the application. In the background, by clicking that button, a token mint has been executed. So nothing fancy here. I assume that are things you can do more or less with every network, right? So let's go back to our sample. And before showing how we can run that against other networks, I would like to do a little bit of coding more low level to show you, oops, what was that? To show you how the SDKs of Hiero are used. So let me stop that one. So this is just an example that, again, wrote out of the .env file those information and then creates a client, which is coming from the Hiero SDK. And what I can do now, I can create a transaction. As an example, I could create a token create transaction, that's the name, and say, okay, I want a token create transaction, and the token create transaction should have set name, which is Rare Evo dollar. I think I have not used that. So we can set a sign, which is the Rare Evo dollar. Then we need to, yeah, we could do that. I don't care currently. Yeah, let's do that. And we need a treasury account, which is my operator account that I have loaded here on top based on the environment. And now I need to sign that account. So which means in the API, we need to freeze that account so that no changes can be done anymore. And then we sign it, and then we will execute that. So that is the full code. And if I now run that one here, will be done in a second. And we go back and have a look at operations here. We see that we have Evo dollar token create. Oh, we only created it, right? We don't minded it. So we created a token, and we created the token of type this one, the Rare Evo dollar, right? So that is how the basic SDK works. So what you can do now, instead of saying I want to run that against the Hedera testnet, you have different options, especially when it comes to testing, to CI, and things like that. And two things that we have is, first of all, the GitHub action that you can use in GitHub that creates a full Hiero network for you, where you can run CI tests against. So when you have automatic tests in your code, we can create one of them. Let's go to tests and say like, oh, we have an Hiero test here, and we want to inject, now we're back in Spring, we want to inject, let's say like the file client of Hiero, and now we create a test, which is void test file client, where we, I don't know, have a string, oops, containing hello Rare Evo, and then we do file client dot create file, and no, it's create file, come on. And we need text dot get bytes. And this now calls a transaction against a Hiero network. We get back a file ID. Yeah, it throws an exception. Let me just do it here. And we get back a file ID. And now we could do another transaction to read the content of that file ID and to be sure it assertions, it should be the same, right? So file content, let's do like a new string from file content should be the same as text. Go away, should be the same as text. Okay, so that is a test we could execute if I need to add a test here. So if I execute that test now, I assume it will work. If I don't did something wrong, yeah, it works. But this is running against testnet, right? And running that tests cost, even if it's a small, but it costs a part of those 1,000 H-bar I have each day. So if I run that maybe 100 times, I'm running out of H-bar. And I have a huge project like our Spring Boot project that has, I don't know how many tests that are run again a network. So running all of the tests of that project, like 4 or 5 times a day, will blow out all the 1,000 H-bar that you have. So what you can do is you can create a network in a Docker container. And to do so, we have currently a prototype that is running a full network. Let me see if it's still running. In a Docker container. Oh yeah, I have it running here. That you can, with just one command line, with just the dependency of Docker, start and have a full network running in a Docker container that gives you, as an output, once it's created, an operator account with a private key that has, I don't know, 1 million H-bar or something like that. And you can use that for all your integration tests. So the problem with that is it's currently like in creation, and it still takes some time to be set up. Let me show it to you. So let's open the README of it. So since the container is not hosted anywhere as Docker Hub or whatever, right? What we need to do is, first of all, we need to create the image. That just takes a second, boom, the image is created. And what I can do now is with Docker run, I can start that container. And as said, that now takes a little bit to set up the container, because what it does, it really sets up everything. It sets up a Kubernetes network by using kind, which is like Kubernetes in Docker, with consensus node, with mirror node, with our JSON RCP relay that brings compatibility to Ethereum, and so on and so on. And all that within one Docker container. And it uses something that we have brought to Linux Foundation Decentralized Trust 2, which is called Solo, which is a CLI tool that you can use to set up and maintain Hiero-based networks, that you can use to add nodes on given servers, to maintain nodes, and so on, which makes the maintenance of a full network way more easy. And that is already used, like we've seen this HashSphere as an example. So that is really used in all those things. And we use it here to create a network on our machine. While that is taking some time, we can have a look at the GitHub action, as I said. So under the Hiero org on GitHub, there's a project called Hiero Solo action, and that is a GitHub action that allows you, as you can see here in the documentation, by just calling it in a GitHub action workflow, setting up a full network and storing account ID, private key, and public key in environment variables again, that allows you as a next step, do whatever you want. One good example for that is, we've seen it, the Hiero Enterprise Java, which is the Spring Boot integration. Because what this does, when having a look at our workflow, it installs Java. Oh yeah, it checks out the repository. It installs Java. Then it uses exactly that GitHub action to set up a full Hiero-based network. And then it will call a Maven verify, which will build the project in Maven and run all tests. And that one really then runs, I don't know how many tests against that Hiero network that is running within the GitHub action, which allows us to write integration tests, and in GitHub, whenever a pull request is created, those tests are all executed within that pull request. So let's have a look. That one is still running here. So if we go to, let's go to any pull request here, I don't know, bump Hiero Ledger version to a new version as an example. What you can see here, oh, that is red currently, because this is a test. And if we go into that one, however, it is red, yeah, it's red in an error. But what you can see here is we're on line 1300, whatever. And what I'm only logging here is all the transactions that are executed, right? Send transaction of type topic update transaction, topic create transaction, topic message transaction. And that is all happened by the integration test that sent transaction against this Hiero network running within a GitHub action. So just within your pull request. Yeah, and we're still waiting on this one. As said, that takes some time. The good one is you only need to set up once, right? You can start it in the morning. It takes 10 minutes, and then you can run it the whole day and have that container running, and you can code against that one if you want to. So we have 7 minutes left. I assume within that time it will be done and we will see the end result. But while we're waiting, are there any questions? Yeah.
So I have some questions. I'm a little nervous. I don't want to ask any dumb questions, but I don't think there are any dumb questions.
Oh, there are no dumb questions.
So my first question would be, okay, so I see that you're able to use it with networks like Hedera and Hedera, for example.
Yeah.
But you're saying that this allows us to build our own network. Am I understanding that correctly?
Yeah, yeah.
So like, what exactly is the difference between like using an existing network like Hedera Hashgraph versus like creating your own? Like,
oh, yeah, okay, yeah.
Can you just kind of explain the difference?
Absolutely, I can do that. So let me first of all repeat the question for the recording. So the question was, so Hedera is already there as a network, and with Hiero, you can use the code of Hedera and create a different network. What is the benefit of that, right? That is more or less a question. So one benefit could be that it's a private network. So let's assume you are a car manufacturer, right? And you have 20 companies who create all those small parts that are needed for a car. So what you can then do is run a network with those 20 companies where each one node. It's a private network. It's not accessible from the outside. Only those nodes know how to connect to each other. And you can use, for example, that network to share like the test data and test information of all those parts. That's a big threat in the car industry, that for each of those parts, you need to have like a full test document about, oh yeah, that part was tested under fire, under this pressure and whatever, you know. And for each part, and we're talking about, I don't know how many hundred thousands of maybe those small parts being created each day, those test documents need to be stored somewhere, need to be shared somewhere, right? Nothing you want to have in the open. But if you have a private network that is shared between some parties based on the code that is used by Hedera and is already proven, you can use exactly that to share it. That is one use case. Another use case is, which is a personal wish for me that we get this working somehow, is that universities work together and create a network where each student get an account with, don't take care about any coins, and can really play with that network, can play with smart contracts and all that on a network that is run by multiple universities. That's another example. I mean, you have projects like Bizu from the Linux Foundation, which is an Ethereum client. You could use Bizu already today to create a private network. But what we do here with Hiero is more, because it's a full distributed ledger technology, including everything like the SDKs, like things like mirror nodes that makes it easy to query the network without paying anything, and so on and so on. Does that answer the question?
Yes, I believe so. Thank you. And just one more. I'll try to keep it simple. So are there any limitations in terms of like what networks you can work with? Like, could you build a multi-chain application with something like this? Or is this more so like working with a specific network?
Oh, okay. So the question was, can you create multi-chain applications with that, or connect with, let's say, like any network on the world, right? So, so the answer is like that. What we're trying to achieve is creating here a base for networks, public or private, that is as far as possible compatible with Ethereum, which means like we have an EVM inside. Every smart contract you can deploy on Ethereum can be deployed on any Hiero network. Hiero contains this JSON RCP relay node that lets you use any Ethereum client like Web3, JS, or whatever, and use it against a Hiero network. What you cannot do is to say like, oh, let's take the technology that, for example, Polkadot is using. I think they now introduced Rust-based smart contracts and deployed like that into a Hiero network. That won't work. What the Hiero network has for that, and I think that is the important point here, it's created in a service-based infrastructure. So when looking at the consensus node, the smart contract part is a service. So this is the smart contract service. Next to that, there is a token service that allows you to interact with tokens by using native transactions of that service. Then there is a consensus service that lets you allow to run a message bus in a distributed thing. Then there is a file service that lets you allow to store files on the system. What you could do is you could create like a voting service or whatever service and bring it into Hiero, and then the network could decide if it wants to, deploy that service in their consensus node. So it's really like a plug and play thing. And in theory, you could say, hey, we want to use technology X for smart contracts and create a service for that allow you to not deploy EVM compatible smart contracts, but for any other chain compatible smart contracts on it. Currently, it's what we have there, EVM, but it's possible to create other services next to it. And we just see it's done here. So we got an account ID, a public key, and a private key. And let's just stop sharing my screen, because I again need to open my environment file here, remove that, and put in the private key, from here, and put in the account ID, that is always 001001. And the network type is Solo something, Hiero Solo Action. That is the name of the network type. In that case, let me now share again. I'm updated the environment, like you can see here. And if I now go to this direct SDK usage and execute it, this will now be, oh, there's a typo. That should be like that. This is now be executed directly against the network running in my Docker container. And I could, like disconnect now my machine from the internet, but then the recording would not work anymore because it's over Zoom. So I don't do that now. But that is how you can work with it, and where we currently working on to make the developer experience as smooth as possible, so that it's really like for an enterprise developer feels like any other tool he's using, like a database or any middleware that he normally starts in Docker, where he has GitHub Actions for, and so on. That's it. So that was what I planned to show today. I hope you liked it. If you have any questions, I'm here for the whole day. You can find me on LinkedIn. Yeah, there's a question.
Well, to ask you, like, exploring a possible collaboration between both of us.
Yeah.
I wanted to ask what are the limitations on the amount of information that you can store in transactions?
So the question was, what are the limitations that can be stored in transactions for an Hiero-based network because of making a cooperation with the Identus project possible? So transactions are first of all have a maximum defined by a size. Like a transaction is allowed to be a max size of, I don't know the exact number, especially since it has changed within the last half year. We now have this huge transaction type that allows you to really do huge transactions, but I don't know the exact size of it. I would need to double check that. Sure, absolutely. Yeah, absolutely. Yeah, we can discuss that offline. Yeah, again, thanks for watching. See you around. Thank you.